polynomial f of x is equal to x to the fourth minus 5x cubed plus 3x squared plus x. Well, right, we got to find all the zeros of this fourth degree polynomial. And you can see immediately that there's no constant term. So we can factor out an x right off the bat. Okay? X is in each of these four terms, and the lowest power of x is x to the first. So we can factor out an x. So we have x times x cubed minus 5x squared plus 3x plus 1. Now, we have to factor this third degree polynomial inside parentheses. And it's this third degree polynomial that we apply the rational zeros test to. Okay. You can see that the constant term is 1, and the leading coefficient is also 1. So it's that third degree polynomial inside parentheses that we apply the rational zeros test to. Okay. All right. So the integer factors of the constant term 1 is plus or minus 1, right? 1 times 1 is 1, minus 1 times minus 1 is 1. And we get the same integer factors for the leading coefficient, right? Leading coefficient is also 1, and its integer factors again to that are plus or minus 1, right? So this applies both to the constant term and the leading coefficient. Okay. So when you take the integer factors of the constant term divided by the integer factors of the leading coefficient, we just get plus or minus 1 again. Okay. So the possible rational zeros in this problem are minus 1 and plus 1. Okay. So the integer factors of the constant term are plus and minus 1. The integer factors of the leading coefficient are plus and minus 1. Plus and minus 1 divided by plus and minus 1 is plus and minus 1. Okay. So there are only two possible rational zeros, okay, for this third degree polynomial. So I put in plus 1 into this third degree polynomial. I have 1 cubed minus 5 times 1 squared plus 3 times 1 plus 1, and that equals 0. So x equals 1 is a 0 of our third degree polynomial, and it's also a 0 of our fourth degree polynomial, right, by default. And x minus 1 is a factor. Okay. So f of x factors into x times x minus 1 times some unknown quadratic q of x. Because this is a third degree polynomial, x minus 1 is one of its factors, and so x minus 1 times some unknown quadratic, right, equals this third degree polynomial. Okay. So if we divide this third degree polynomial by x minus 1, we can get the unknown quadratic q of x. So q of x is equal to the third degree polynomial divided by the factor x minus 1. Right? X minus 1 times q of x equals this third degree polynomial. So if I divide this third degree polynomial by x minus 1, I get q of x. Okay? Well, x minus 1 is linear. Okay? That's x to the first power. So we can use synthetic division, right, to divide this third degree polynomial by x minus 1. So 1 goes in the box, and then the coefficients of our third degree polynomial are 1, minus 5, 3, and 1. And now we perform the synthetic division. Bring down the 1. 1 times 1 is 1. Minus 5 plus 1 is minus 4. Minus 4 times 1 is minus 4. 3 minus 4 is negative 1. 1 times negative 1 is negative 1. And 1 minus 1 is 0. So we have a remainder of 0, which is what we expect. Okay? So these are the coefficients that go with the quotient of this division. Minus 1 goes with 1. Minus 4 goes with x. 1 goes with x squared. And so the result of our division is q of x is equal to x squared minus 4x minus 1. All right, you multiply each coefficient by its x term. Okay. So over here, we can now fill in for q of x. Q of x is equal to x squared minus 4x minus 1. So we factor this quadratic. We find the values of x and make that quadratic equal to 0. And we find the last two zeros from the last two factors. Okay. All right. So we set x squared minus 4x minus 1 equal to 0. And then we solve for x. Okay. Well, actually, I'll put this up here. So in this example, a is equal to 1, b is equal to minus 4, c is equal to negative 1. So using quadratic formula, x is equal to negative b, which is the negative of negative 4. And we have plus or minus the square root of b squared, which is minus 4 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 2 times 1. And now you got to simplify. Negative 4 is plus 4. Minus 4 squared is 16. And minus 4 times 1 times minus 4 is plus 4. All divided by 2. 16 and 4 is 20. 4 plus or minus the square root of 20 over 2. And square root of 20 reduces to 2 root 5. And again, fraction bars are like division symbols. Division does not undo addition and subtraction. So we have to divide each of those terms in the numerator by 2. And so we have x is equal to 2 plus or minus the square root of 5. So the last two zeros are x equals 2 plus the square root of 5, x equals 2 minus the square root of 5, and then we add them to the first two zeros. Okay, I guess I didn't write it out, but x equals 0 is a 0, right? F of 0 is equal to 0, right? You put in 0 on for x, you have 0 to the 4 minus 5 times 0 cubed plus 3 times 0 squared plus 0, which is 0, right? That's the result of factoring out the x. Okay. So x equals 0 is the third 0. And we already showed that x equals 1 is a 0. So these are the 4 zeros of our original polynomial. Okay. And now we can factor x squared minus 4x plus 1 because we know what zeros are. Okay. So we have f of x is equal to x times x minus 1 times x minus 2 minus the square root of 5. Okay. Remember, you just subtract, move everything from the right-hand side to the left-hand side to get the factor. Right, the factor theorem says if x equals c is a 0, then x minus c is a factor. And then finally the fourth factor is x minus 2 plus the square root of 5. So that gives us the complete factorization of f of x. So those are the 4 zeros, and this is the complete factorization. Okay. Any questions on that?